Hopefully many of you were able to attend the GRF web panel hosted by ICAO Asia Pacific Regional Office this past Tuesday. In that event, we received an operational, historical, and implementation planning perspectives on GRF. This was provided by experts from Airbus, Friction Task Force, and EASA. So the intention of this introduction is to bridge Tuesday's event to today's event on SNOTM. And therefore, I'll provide an introduction on global reporting format. So I start with, what is GRF? GRF is the new ICAO methodology for assessing and reporting runway surface conditions and enables the harmonized assessment and reporting of runway surface conditions and correspondingly improve flight crew assessment of takeoff and landing performance. GRF at this time will be applicable on 5 November 2020. This implementation is expected to reduce the risk of runway excursions since GRF improves the accuracy and timeliness of runway condition assessment and harmonizes this information globally. So why GRF? Let's start with the problem statement captured in the Air Navigation Commission job card. Runway surface conditions have contributed to many safety events and investigations have revealed shortfalls in the accuracy and timeliness of assessment and reporting methods currently provided for or in ICAO provisions and guidance material. Furthermore, pilots of modern aircraft also need reports that are directly related to the performance of the aircraft. The ICAO structure to work on this job card was performed by establishing the Friction Task Force, which is under the Aerodromes Operations Panel. The rapporteur of the Friction Task Force is Armand Norheim of the Civil Aviation Authority of Norway, who has also contributed in a lot of our implementation events, and much appreciated. As you can see, provisions related to GRF were developed in order of a decade with provisions available beginning in 2016. So you see here, there were many ICAO provisions, provisional documents updated with the development of GRF. Our focus today will be on the aims section highlighted in red, but I'd also like to note that the Doc 10064, the Aeroplane Performance Manual, was just made available on the ICAO net in the last day. And that's the unedited English version. So there'll be a disclaimer when you go there. But fortunately, there's information available as of some hours ago. So when reporting runway surface conditions, the aerodrome operator assesses the runway surface conditions whenever water, snow, slush, ice, or frost are present on an operational runway. And the aerodrome operator produces a runway condition report called RCR. RCR is a comprehensive standardized report relating to the runway surface conditions and its effect on the aeroplane landing and takeoff performance. RCR contains the runway condition code, which maybe you're familiar with by now, and information which describes the runway surface condition by providing the type of contamination, thickness, and coverage for each third of the runway. Runway condition code will be used as input data for compiling landing distances with data provided by the aircraft manufacturer. Also, we should note that reporting runway surface conditions, there is an aeroplane performance section, as well as a situational awareness section. As you see there, all the elements in red, what do they represent? They're required to be reported, such as aerodrome location indicator, date, time of assessment, lower runway designator number, runway condition code for each runway third, condition description for each runway third, and the others listed are not mandatory. However, if available, should be reported. Situational awareness section contains information in a string such as drifting snow on the runway, and that's followed by a full stop. So this impacts quite a few people, groups, stakeholders, and we included a short list, basically. In the first one, aerodrome operators who assess and report runway surface conditions and send the RCR to Air Traffic Service and Aeronautical Information Service. Airline operators and manufacturers, as the airline operators, use the runway condition code as input data for compiling landing distances with data provided by the aircraft manufacturer. We also have the pilots who provide runway braking action, special air report to the aerodrome operator, particularly when conditions encountered are different than reported. And then air traffic services report RCR to pilots via ATIS and/or radio. Finally, for you, Aeronautical Information Management, report RCR via the new SNOTM format when applicable, which we will get to momentarily. I also want to note here that list is not comprehensive. For example, the CAA is oversight for the implementation. So we have this runway condition assessment matrix, which includes the assessment criteria. Runway condition code is linked to the runway surface description, such as 6 represents a dry, 0, wet ice, and many things in between. Also, this matrix describes how this assessment criteria relates to aeroplane performance. That is the description of aeroplane deceleration or directional control observation and pilot report of runway braking action. So let's try to create one runway condition report. So for the aerodrome BB, runway 0422, an assessment was made on the conditions of the runway. On 14 August 2019 at 1600, there was significant rain. So the first runway third has 33% coverage of water, 4 millimeters deep. The second runway third has 20% coverage of water, 5 millimeters deep. And last runway third has 50% coverage of water, 4 millimeters deep. And there you see your code. So you see BB, the airport ID, the date time indicator, the lower runway designator, and the condition code of 222, which relates to standing water, standing water, standing water, and the percent coverage and the depth in between. So basically, we're at the RCR. That's where we want to be. Since RCR is sent via the new SNOTM format in some cases that Abbas will now describe in his presentation. Thank you.